Is this model structural? It's a question that can start a fight at an economics conference. But here's what I'll show you today. The answer isn't yes or no, it's how structural. Because structural isn't a binary, it's a spectrum. And understanding the spectrum will help you understand which methods to implement in which kinds of situations. As we've covered in a previous video, most economists think there are two types of models, structural and reduced form. Structural models typically make strong assumptions about equilibrium conditions and preferences, while reduced form methods typically analyze policies in a design-based manner, meaning quasi-experimental or experimental manner. But as economist Phil Haile says, all empirical work is either descriptive or structural, and it just depends how many assumptions or what level of structural we're dealing with that distinguishes between methods that we're going to use. So what makes something structural? Well, typically, a more structural method is going to implement more behavioral assumptions. These would be things like preferences or technology. A structural method is also going to recover a so-called deep parameter, which is a parameter or description of the world that's not going to change if policy environment changes. Structural models, or models with more structure, will directly model different mechanisms through which treatment affects outcomes. And finally, models with more structure will be able to say more about the generalizability of treatment effect estimates. Let's talk a little bit more about these deep parameters or structural primitives that we might hear talked about in structural modeling. These parameters are typically the building blocks of human behavior. These include things like preferences. How do consumers prefer different goods? What prices as a function of their income? It involves technology, and technology could be production functions. How do inputs translate to outputs? But it could also be matching functions or search frictions. Information and expectations are a big part of these deep parameters or economic primitives. Things like beliefs or learning or updating of expectations. Demographics, because the types of people who are making decisions matters. Are we looking at mothers? Are we looking at elderly? That's going to matter for our question. And then finally, networks and social interaction, which govern how people interact with each other, how information is shared, and so forth. And again, the idea is that these fundamentals, these economic primitives, won't change as the policy environment changes. So now let's talk a little bit about how we could maybe get the most bang for our structural buck. And I want to talk about sufficient statistics and structural parameters. There's an influential paper by economist Chetty who talks about essentially doing the 80-20 rule, meaning doing 20% of the effort to get 80% of the benefit of a more structural method. So what Chetty proposes is sufficient statistics, which are basically elasticities or other types of answers that you could get from a less structural method, and then using those combined with a theory from which a more structural method would be derived to arrive at a final answer about welfare gain of a particular policy and so forth. So the sufficient statistics are readily computable, and they can tell us something under the right assumptions in the right situation about the more complex structural model that we would like to know the answer to, but may not be feasible, may not be economical to do all that work. Then on the other hand, if we need to, we may need to go that final 80% of effort to get that final 20% of benefit to answer the question that we need to answer. And so these primitives or these deep parameters would, instead of being these simple elasticities, like what's the price elasticity of demand for product J, they might instead be questions like, why do consumers prefer good J over good K? What is it about the environment or the demographics that is making them choose a particular good over a different one? And so the idea is that, yes, these sufficient statistics can take us far along to get to the answer that we want, but in some cases, if we really need to know the correct answer, we're going to need to go the full distance. So let's just kind of paint a picture of the different degrees of this structural versus reduced form, or less structural versus more structural spectrum. At the least structured level of the spectrum, we have descriptive work. So an example here would be college graduates earn 50% higher wages than high school graduates, an estimate from a descriptive analysis. If we wanted to add a little bit more structure, there's an influential paper by David Card who tried to estimate the returns to college, not the descriptive difference between college graduates and high school graduates. And he proposed to use distance to college while one was in high school as an instrument for getting a college degree, which would then affect the wages. So this is a model, this is an instrumental variables model that has a little bit more structure because it's making assumptions about how the distance that one lives away from a college when they're in high school eventually results in higher earnings as an adult. We could even go one step further. So we could instead actually model preferences for attending college versus working without a degree, and then from those preferences, we could simulate what might happen if we change tuition or if we vary where someone grew up or so on or so forth. So that would be a model with even more structure because we'd have to make particular assumptions about what's the shape of their utility function, what do they have preferences over, and so forth. And then finally, we could have like the most structural model, which would incorporate maybe general equilibrium effects or entry and exit of colleges, or maybe it has additional occupations that people could work in, and so forth. So the idea is that we make more assumptions, we get more out of the model, but then some people may not agree on the assumptions that we're making. And that's where we lead to this disagreement about methodological differences. An insight I really like from Arthur Lewbel's paper on the identification zoo is something he calls crude structural modeling. So if you're reading a paper that uses a less structural method, typically a design-based inference paper, what you're going to find is that at the end, the authors are going to measure their treatment effect, they're going to do the usual diff and diff or IV, and then they're going to speculate about why the treatment effect is what it is. So typically you'll see some discussion and they'll say something like, well, we document this effect size and we have suggestive evidence that this is what's generating that effect size. What Arthur Lewbel says is that this is actually crude structural modeling. You're making assumptions about how the outcome is being generated from the treatment, but you're not putting any formality around this analysis. And so Lewbel kind of points out that if you want to tell a credible story about these mechanisms and how they're operating, then you need to have additional assumptions and add more structure to the model. So now that we kind of have established that there's a spectrum of structural modeling, what are the pros and cons of each end of the spectrum? So on the less structural side of things, we're typically going to find that these methods are much more easy to compute so that we will arrive at estimates in a much more timely manner. And we won't have to make as many assumptions, or we'll be able to make assumptions that are easier for our reader to understand what we're assuming and what we aren't. And these methods are going to be useful for policy evaluation, which means that we're going to be able to use these methods to analyze policies that have already been implemented. Now, the downside of these less structural methods is that we're going to have to answer much narrower questions because the results that we get from our analysis are not going to be portable across contexts. So they're not going to be very generalizable. On the other hand, as we add more structure, that buys us portability across contexts because we're estimating deep parameters that are invariant to different policy environments. And that's going to allow us to analyze broader questions and be able to say why, be able to decompose treatment effects into different mechanisms. And what this amounts to is that this is going to allow us to design optimal policy if we add more structure, because it's going to allow us to consider policies that have never been implemented. So that's what I mean by policy design, is we're considering, well, what is the optimal policy for this particular question that we're interested in? On the downside, these more structural methods are going to be much more computationally intensive. They're going to rely on typically more difficult to understand assumptions about identification and so forth. And so that's going to make them less timely or more time intensive in terms of how much effort is going to be required to get the results to share with others. And in turn, this is going to possibly require specialized computational skills beyond, applied linear regression models and so forth. In the end, neither of these extremes of this spectrum is better than the other. They involve trade-offs, and so it's more important to know, why am I choosing the amount of structure on my model that I've chosen than it is to say, well, this is the only right way to do this. So just remember that every empirical economist is a structural economist, and we just disagree about how much structure we want to impose. So next time we'll talk about how and why you might need more structure and when you might not. So I hope to see you in the next video.